Right, a ball is launched, angle theta. It's got speed 1 meter per second. So this is 1. So we need, and I believe you get a method mark for just writing, let's say that's A. And it's asking find the horizontal and vertical displacement of the particle at time t seconds. So you can leave that in terms of t. And it says horizontal and vertical. So obviously that means horizontal is this way, and then we want the direction this way in terms of theta and t. Okay, you've got S equals u t plus a half at squared. That's how we start this off. If we resolve vertically first, let's resolve vertically, resolving vertically. Do we have? We have, let's start this off. In the vertical direction, that's the opposite, so that must be 1 times sine theta. We should remember that. And horizontally must be 1 times cos theta, which is obviously just cos theta. So we have this, we have u equals sine theta. T is t, because we're leaving it in terms of t. And does it say a? Just be careful, it does say a equals minus, so a will be minus 10. That's how we start it off, and we just substitute this in. So we're going vertical direction. I'm just going to call that sy. So we know it's the sort of like the y-axis. So we get u, which is sine theta, times t. So that means we can just substitute that in and say that's t sine theta plus a half times minus 10 times t squared. So that's simplified, and you can just call that y, I guess, as well, the vertical displacement. So you could just leave that sy or y, but just because that s looks like a 5, I'm just going to write y here. And you should see that's just going to be 2 sine theta, and minus times a half, that's going to be minus 5t squared. So, like I said, that gives you a method mark. Substituting your values in as a method mark. This is going to be another mark because that's the vertical displacement formula. Now, resolving this way, so this way we've got u equals cos theta. Now a, well, that's acting down, so a is 0 here, correct? T is still t, and we still use what we have here. So we substitute that in, and then we get, all we get is, so I'm going to call this x for horizontal, so x must equal u times t. So I'm going to write the t in front, so that's just t cos theta. We know a equals 0, so 0 times everything 0, and essentially that is it, and that's another answer mark. So it's doable to get 4 out of 4 there. I think you could all get 4 out of 4. B, it says, show that the horizontal distance travelled by the particle before it hits the ground is sine 2 theta over 10. So what do we know? How can we do something for when it hits the ground? So when this hits the ground, this is the vertical displacement here. What does y have to equal? What does y have to equal? And we're going to use part A to solve B. So we're going to use this. So what does y have to be? Yeah, 0. Well done there. So y equals 0 here, because that makes sense, because y equals 0 at this point, and y equals 0 at this point. So we should know it's 2 answers, and this is modelled as a quadratic, isn't it? A negative quadratic. So we're going to get 2 values. So we can set that to 0, what we wrote above. Y equals t sine theta minus 5t squared. So don't know why I wrote squared there. Squared should be like that. Now, so we can just factorise that out because there's t's in both terms. So then we can write 0 equals t sine theta minus 5t. Okay, and that will make sense. T equals 0 is one answer. T equals 0 is here. right? So the other answer we have to know is when sine theta minus 5t equals 0. Now, we might think, well, we still don't know what t is, and we do need the time, because once we find the time, we can use that to find the horizontal distance that it's travelled. So what can we do here? We just get t in terms of sine. So what we get is phi t, just plus a phi t over, phi t equals sine theta. So t equals sine theta over 5. So this is the time that it takes for when it hits the ground. So what can we substitute this into? What formula can we substitute this into? I call that equation 1 and equation 2. Yeah, sub time into the horizontal, that's the only one we can do. So I'm going to write sub into 2. So x equals sine theta, that's all over 5, cos theta. Now, I don't know if you've done your trig identities, but I'm going to write it here. Sine 2 theta equals 2 sine theta cos theta. You might not have done that yet in year 2. So that's how you unlock that. You see, so you can see you have to apply all your A-level knowledge to answer some of these questions. So if sine 2 theta is over 2, can you see this is the same as writing this? Equals 2 sine theta cos theta over 10. Because you just multiply top and bottom by 2. And then you've, oh, sorry, that should say 2. That's 2, so that is sine theta over 10. Sine 2 theta over 10. Because, yeah, so what I mean is here is if we turn that to x equals 2 sine theta over cos theta, that will be over 10. That changes because 2 sine theta cos theta equals sine 2 theta. That top will change to sine 2 theta over 10. And then you would know that if you knew your pure 2 stuff. You got there. Okay, so that's part B. But you can pick up lots of method marks there, hopefully, by just substituting, rearranging, substituting, and that's the skills you need to do. Right. So this is C. Find the value for theta for which the horizontal distance travelled is a maximum. This is a thinking skill. So what angle is theta going to be? It's worth 2 marks for it to be a maximum. So they will have a think. What do you need to do? So I'm going to give you a little clue here. Think about it. What is the highest value sine theta can be? If I was to draw the graph of sine theta, what is the highest value it can be? Okay, so let's draw the sine graph so you would understand. This is just a graph of sine x. Ooh. We know that sine x goes from 1 to -1, right? And it goes like this. So we want, obviously, to get the maximum horizontal distance, we want the value of sine x to be as high as possible. So sine x has to equal 1. So we want sine x to equal 1. Because if it's a smaller value, it's going to decrease the distance. Yeah, well done, William. So that's what this question is asking. What value of theta? Now, we want this number as big as possible. So, but this is asking what sine 2 theta is. But if we want that to equal 1, now, what is that value here? That's 180, right? So this must be 90. But because it's in the term sine 2 theta, we have to do 90 divided by 2 equals 45. Because then we get 45 times 2 to get that as big as possible, which will give you the maximum horizontal distance. And that hopefully makes a bit of sense to you now. And I can see you haven't seen a question like that, so you could get caught out. But that should make sense. So are we happy with that? Yep. Okay. Now part D, you should be all be getting this mark. Okay. So you can say, which is the most common one. This does not. It's traveling in the air, and because it is a model, so you know it does not include air resistance. And you could also say they grounded gravity to 10 meters per second. G equals they should have set that really, not 9.8. So do you want to take a note of that? Remember, I'm recording this, so I will put this online. Or can I move on? And that's 20 minutes. Okay, so what I'm going to do is move on. I think I'm going to do that one later. And can you see this question was very similar to what you had in your mock? The skills are the same. And this is a past exam question as well, I believe. Okay, let's go on to, let's choose, don't want to do that one yet. Let's do this one. Right, I'm going to let you have some time to read the question. Same thing, I'm going to start you off. So we know in the vertical, that's u sine 45. And that's u cos 45. That's all we know so far. Remember, just write s equals ut plus a half at squared. And then first step is to resolve horizontally. Okay, so resolve horizontally. And I think you should be able to try that out. The ball hits the ground at 100 meters. So we resolve horizontally, we know S, we're going to get 100 equals what? And I'm going to write what U is. Now this is a bit weird because we're using U and U. So let's just call it U. Let's just call this U like this so we can see that's the U from the initial. But horizontally, that is U cos 45. Okay. Remember horizontally, we don't have A, so A equals 0. So we've got this distance 100. We know the distance is going to be 100. 100 equals U, which is what we're using here, U cos 45t. Now to make it easier, always use your whole values, but you should know, or you can use your calculator later, cos 45 equals root 2 over 2. Because we're gonna need to do that because we're gonna have to show U equals 28. So what's the next thing we need to resolve? Which direction? So these type of questions always resolve horizontally, then vertical. Thank you. So let's resolve vertically. So you going this way up. You don't need to do this normally. It's very rare to use the same letter because that's confusing. So U going up is U sine 45, right? Now with this, we do have A equals, as it said, 3 under gravity. So I believe we have to use A equals 9.8. And that's minus 9.8 because if we're going up, gravity is going down, so A equals minus 9.8. Now, the difference with this question is, can you see we're starting at 25 meters up in the air? And this is displacement. So what is S going to be? What is the displacement? Like displacement in terms of Y? Because you have to get this right. Otherwise you will not get to the answer. This is the start point. Imagine that is the 0, 0 on an axis. So what is S going to be? Minus 25, correct. If you don't get that, you won't be able to complete the question. So we can substitute this all in and get minus 25 equals, substitute it into here. So we've got U sine 45 times T, U sine 45 times T. I'm just going to write that lot. Minus 9.8, half of minus 9.8 is minus 4.9, so it's going to be minus 4.9 t squared. So I'll write this above because these shouldn't match. We've got 100 equals u cos 45t, because we can do something and cancel something here. Now let's think, you got to realise that cos 45 is actually the same as sine 45. That's the key to unlocking this. So we can just use the numbers here. So what happens is this becomes 100 equals u root 2 over 2t, and this one becomes minus 25 equals u root 2 over 2t minus 4.9t squared. Can you see we've got a nice simultaneous equation where we can cancel out the u's? So we minus the top by the bottom, minus and a minus is a plus, so we're going to get 125 equals that, these two will cancel, and minus and a minus equals 4.9t squared. So we're going to get t squared equals 125 over 4.9. When you square root it, so let's do arrow, so t will equal plus or minus 25 root 2 over 7. So we use this value of t in any of our formulas, and the easiest one will be this one. So we just use 100 equals u cos 45, so that's u root 2 over 2 times our value of t. Now obviously t is going to be the positive value because it's time, which would simplify. So root 2 times root 2 is 2, but that 2 over 2 will cancel, so you'll get u 25 over 7, and if you divide out by 25 over 7 on both sides, you will get u, which is capital U in this instance, equals 28, and that is your 6 marks. Right, do you think you can do part B, or do you want me to do that as well? It's a lot of steps, but I believe you can get there. What would you like me to do? Yeah, give it a go for 5 minutes, because it's a 3 mark question, so maybe I'll give you 3 minutes. I'll leave that up there so that you can give it a go. So depending on what SUVAT formula you use, we can use, hello Derek, we can use v squared equals u squared plus 2as. Now remember, it's the greatest height above the horizontal ground, so we do have to use this. Remember, u, the big U in this question is 28, because s will give us the height. Now the key to unlocking this is the greatest height. Remember, the greatest height is when v equals 0, because when this is shooting up its speed, when the gravity hits like so, v is 0 exactly there. So that's what you need to remember. And you still have a as minus 9.8, I believe. And then you should be able to do that question, which is a nice 3 marks. That's just something you remember. I know some of you are good at remembering that, v equals 0. So we've got u, v and a, we can use this. Anyone got an answer? You got 45, yeah, well done, because, yeah, that is perfect. You are correct, because essentially you'll get u equals, we know v is 0, so 0 equals u squared, which is going to be, I remember I've got to use this u, that's 28 sine 45 minus 2 times 9.8, so minus 19.6. And instead of this S, I'm just going to call S the H, because that's the height. Rearrange 19.6 H equals 28 sine 45. So we get H equals, and you can just do this on your calculator, times sine 45 over 19.6. And you should get an answer close to 20. So H here is 20 to the nearest whole number. But remember, it starts 25 meters above the ground. So you have to do 20 plus 25 to make 45 meters. Now it says part C is how would this new value of u compare with 28, the value given in part A. So remember, in the refinement of the model, the motion of the ball from O to A, the effect of air resistance is included. And the refined model is used to find a new value of u. So what you're going to, if you've got air resistance included, the new value of u in the model is going to have to work. If air resistance is going to be included, the new value has to be greater than 28 meters per second, because air resistance is included. So u has to be a bit faster than initial projection. D, how can it be more accurate? Now you can get one of these marks in and you skip the X. State one further refinement to the model that will make the model more realistic. What could you do with the model? So they added air resistance to make the model more realistic. What else could you do? So if you do physics, one of the acceptable answers in physics, they use G as 9.81, right? So you can use a more accurate value for G. And remember, this is all modelled as a particle, so you could not model as a particle. Now that's 11 marks. The other one was what, almost 13. So 11, that's 11 out of 50. That's 11 out of 50 for your entire mechanics exam, which that's at least worth a grade or two, acing those. But even if you get half marks, that's still getting somewhere. A lot of that is you can do, and I do understand these are challenging. There's a lot to do here. So I'm going to give you, do you need a chance to note any of this down, or can I move on? And that's a lot to process and a long time to listen to all of that. Are we okay? What do you want to do? If you think, yeah, I can definitely get some marks, that's still an improvement. So let me know what you want to do. Or do you have any questions about that so I can explain in more detail? You're good? Okay, so I'm going to move on. I'm only going to get time to do one more question now. So I'm going to let you choose. So show that u squared equals 2g sine theta. So we don't have a horizontal distance, but we have a vertical distance. Now in the vertical distance, it's starting here. V is at its highest when it hits here. So V equals 0 here. We've got V equals 0. Let's do this. So this must be u sine alpha. Just because we might need this later. That's u cos alpha. So the clue here is we've got S as 1, which is the height, because that's how far it travels when V equals 0. We know u equals u sine alpha. A is, oh, there's a g here, so you just got to leave A as minus g. So what that formula can we use? And this u squared is a clue. So it's got to have a u squared in it. So you get formula that has v, s, u and a only. It's going to be v squared equals u squared plus 2as. And I'm going to give you a minute or two. I'm going to start you off with that, substitute in, rearrange it to get this answer. You should be able to do that for a nice 2 marks. And just let me know when you're finished. Done, well done, Derek. So that is a 2 marks that you can all get. So essentially you just substitute that all in, so you get 0, and I'm sure Derek has got it right if you can show that. U equals u sine alpha all squared plus 2 times as. A is minus 2, so it's minus 2g because s is 1. So you get 2g, or should I expand out? Well, actually, yeah, 2g, just jump a step because that was done. You could rewrite that as u squared sine squared alpha. So that's clear. And then you can see u squared equals 2g over sine squared alpha. Right, I'm just going to change colour for part B. Right, so the point T is at a horizontal of 20 meters from A and 0.75 meters above the ground. The ball reaches T without hitting the ground, which is clear from the picture. Find the size of the angle alpha. Now that's a big 9 marks. So I'm going to ask, do you want to give that a go and see if you can get there, or do you want me just to go through it? Start B here, just in case I run out of room. Okay, give it a go for 5 minutes. I'll give you a clue here. You do use s equals ut plus a half at squared. And you're going to have to use a horizontal and vertical formula as well. So resolve vertically. I'm going to give you the dimensions from the question. So horizontally, s equals 20. The u, that's why, little u equals capital U cos alpha. A equals 0 and t equals t. Well done, William. Because yeah, even if you get 2 formulas, see what you can find, like same skills as before, slightly different, see what you can do, just so you can pick up lots of method marks at least. I'm just going to give you a bit of help here, just in case you missed this out, and that will just start you off. Vertical, well that's 2 and that's 0.75, here to here is 1.25, so your S is minus 1.25. Your little u is still, you can know that's the vertical, u sine alpha. A now is going to be minus g, they haven't told you what A is. Oh, and t equals t. And you're always going to use in for both. S equals ut plus a half at squared. I'm going to put that here. Make t the subject. For this part, because that's easier to do. You're a bit lost. No problem. I mean, this is year 2 mechanics. This is a tough question. So let's just go to this one horizontally. If we to substitute this into s equals ut plus a half at squared, we would get 20 equals u cos alpha t, correct? Because the second part here will cancel because a is 0. So if we made t the subject, t would equal 20 over u cos alpha. Actually, this is a 9 marker, so this is actually a really challenging question. Okay, so we've got that. This is important. So we've got to do the vertical motion. So we're going to get the minus 1.25. Got loads of space here. So we're going to get minus 1.25 equals u sine alpha. Let's just put in the bracket t minus a half gt squared. Now we're going to sub this into here for t. So I'm going to get minus 1.25 equals u sine alpha 20 over u cos alpha and so forth, minus a half g 20 u cos alpha all squared. Now, this is when you're year 2 pure. Once you finish that, will help you a lot. If you can see u sine alpha over cos alpha, I'm just going to write sine x over cos x. We know that equals tan x. All right. So that's going to just cancel out to 20 tan x, simply because u divided by u here will cancel out. So that becomes 20 tan, not x, but alpha. Right, if you was to expand all of this, 20 squared is 400, a half of 400, so you would get 200g u squared cos squared alpha. Now you know this u squared equals this, so you could sub that in. I'm going to run out of space. Over 2g sine squared alpha times, and the cos will be up here, alpha. Now, hopefully you can see g's will cancel. Now, if we do cancel the 2's as well, this will become minus 1.25 equals 20 tan alpha minus 100 over cos squared alpha sine squared alpha. Now, when you divide fractions, you should know it's keep, change, flip. So if you keep the 100, flip the sign, or flip the fraction, that will become that, right? Because what we're asking you to do is 100 divided by this. So keep, change, flip, that will become this. So we know that's tan squared. Theta instead. So you get minus 1.25 equals 20 tan alpha minus 100 tan squared alpha. And you can see that looks like a quadratic equation that we can solve, but let's make it nicer. We can multiply everything by 4 to make that 5, so times everything by 4, so we get 5 minus 5 equals, no, let's times it by, what am I talking about? Times it by, yeah, times it by 5. Times it by 4 equals -5. That's correct. Times that by 4 is 80. Minus 400. Rearrange that to 0. So let's, right, if I go next page, I'm not going to get there, so I'm going to jump a step. Where can I write this? I'm going to continue over here in green. So you're going to get 400 which we'll be able to factorize to that for tan alpha minus 1 equals 0. So you solve for both, which you'll get, to make it 0, tan alpha equals minus 1 over 20, and for the other bracket, tan alpha equals 1 over 4. So you get alpha equals minus 2.9 when you inverse tan, and this one, alpha equals 14 degrees. So that's minus 2.9 degrees, so that's saying that answer is like this, right? Because it's minus 2.9. But you can see it's shooting upwards, so the answer must be 14. It must be between 0 and 90. So the answer is 14, like so. So that is very tricky, but that's why I say, like, do re-watch these again in the future. Make sure you can do it on your own. Right, so just finishing off part C, state one limitation of the model, and you could see that there, you could just write there is no air resistance in the model. Now part D, from B, we're going to have to use T equals 20 U cos alpha, and we know that alpha was 14 from before, 14 degrees. Now we have U squared equals 2G sine squared alpha from A here. So we just substitute these values in. We've got U squared equals 2G over sine squared 14. So we get U squared equals 3.2. We get a value of U equals 18.25. So once we know what U is, and we've got this from part B, we just substitute that in. So T equals 20 U, which is 18.25 cos 14, and we get T equals 1.13 seconds, which is the time it takes the ball to reach here. Okay, that is done. So do remember to try these questions again. They are this one is particularly tricky with so many steps, but you can certainly pick up some method marks.